Hi and welcome to C Programming. In today's lesson we're going to do the memo for an advanced calculator problem. So let's read the question and start answering. So the question is, we need to create a menu-driven C program that will simulate an advanced calculator application. The application will enable the user to select the following: 1 power, 2 circumference, 3 triangle surface, 4 factorial, and 5 to exit. Here's our formulas for each of those selections. The power function works as follows. So 4 to the power of 3 is 4 times 4 times 4 times 4. So that is the power function. Then a circumference function is going to be then pi times 2 times the radius. Triangle surface is going to be base times height divided by 2. And the factorial function will be n factorial is then n times n minus 1 times n minus 2 until we get to 1. Meaning that 4 factorial will be 4 times 3 times 2 times 1. Okay. So that is the question. So let's go further. A sentinel controlled do-while loop structure must be used to enable the repetition of a menu until the user wishes to exit the application. A switch selection structure must be used to determine which choice the user made. A counter-controlled for loop structure must be used to solve user selection 1 and 4. Okay, so for power and for factorial we need to use a counter-controlled for loop structure, and if-else selection structure must be used to determine if the base parameter of selection 1 is negative, positive or 0 to determine the correct answer. The math.h library may not be used in this program. Okay, so we need to do the actual calculation for the power and factorial on our own. We cannot use the math.h library. Then each user selection between 1 and 4 must be solved inside a self-written function. No printf or scanf statements may be used inside the self-written function except the display function. Okay, so each function will then go and determine the answer, and then we will display from the main. Okay. Each function must return the correct answer for the given calculation, and the following function prototypes must be used inside your program. May not change parameters or names of the function. So we need to use this as is. Okay, and there's some of our output. Okay, but this is actually quite easy, so let's start. So what we will do is we will open code blocks. We will create a new empty file, and we're going to save this at advancedcalc.c. Okay, and I'm going to save this, and let's start by doing our inclusion of our standard input and output library. Okay, and we save. So we've got our main function here, and let's build and run and see if our program executes successfully before we continue. Yes, so everything executed successfully. Okay, next up we need to go and then do the function prototypes of the question. So we will go and create that function prototypes that was given to us. Okay, and what I will do is I will place the question here on the side. Let's quickly bring it down here. Great. So first of all, we need to have a display function, and it's going to be display. Okay, that's our first function. The next function is float power function. Okay, and we will give a parameter int base. and then int, oops, just change base, and then int power. Okay, semicolon. And then our next one is going to be float circle circumference, and it's going to have a int radius as a parameter. The next one is going to be float triangle surface, and triangle surface will have an int base and an int height. Next, our last one is going to be int factorial function, and the factorial function will have a n as a parameter. Okay, so this is our function prototypes that was specified, and we need to go and use them. Then we will start to do our sentinel control do while loop structure. So what we will do is we will create our do while, and we will have a condition. Okay, so we will have a do while. It said we need to use a do while, and then a selection structure must be used to determine which choice the user made. So then inside our do while, we will have a switch structure that must be used, and then inside our switch structure we will do then the options of, in case it's a 1, we're going to do something, and that will be then power, and then in case it's a 2, we will do then the circle circumference. Then in case it's a 3, we will have the triangle surface, and lastly case 4, so 1, 2, 3, 4, we will have our factorial. And then what we normally do as well with a switch statement, just to check for invalid entries, we can also use default. So default will be our invalid entries, and it's easy to check for invalid input with our default invalid input. Right? Input. Great. So we've got our switch statement here, our basic structure for a switch statement. We've got a do while, and now we need to go and start. So first of all, let's go down to our example here. So what we need to go and display is welcome to advanced calculator. So what we will do is we will call the display function to do the display for us. So we will call display, and then display must go and do these outputs then for us. Okay, the display function is not going to do the scanf because the display function is not returning anything, so we're going to do the choice input after the actual display function. So what we will do is we can do a getch, or we can do a scanf. So I'm going to do a getch. So I'm going to create a variable called, oh no, we don't have to do getch, we can just do it with integer if we really want to. There was no specifications concerning if we need to do a character or an int, so let's do an int, it's going to be easier. So we do %d and %choice. So choice is the integer, and we're going to grab that input from the user, and then we're going to use the choice variable in the switch, and the switch will then go and determine 1, 2, 3, 4. Okay, so the first one is going to be power, so it's going to be our power. Then after Secondly, it's going to be our circle. Let's add it here, circle circumference. Okay, then 3 will be our comment first, triangle, surface, and then lastly will be our factorial. Now each one of these have different input. Okay, so inside our case 1, we're going to ask for a base and a power for our power function. So what we will do is we will say not scanf, we're going to say printf first, and we're going to ask the user for a base. Okay, and then we're going to scanf for the base. Then we're going to ask printf, we're going to ask for the power, and then we're going to scanf for the power. So we need two variables here. We need to have a int base, and we're going to only work with integers, and we're going to have an int power. Okay, so we're going to scanf those values, and we're going to say int percentage d ampersand base, and then percentage d power. Let's make them small letters. Okay, the reason I just want to make it small letters is because our parameters are capital letters here. It won't make a difference, but just to know the difference between our local variables and our global variables. Or not global, but other local function variables. Okay, so now we've grabbed that input, base and power, and then we need to go and call the function, the power function. And the power function will be then called, and then we will say printf, and we can make an answer variable. Okay, so the answer variable will be or what we can do is we can print it inline. It's going to make it much easier. So we can say the answer is equal to percentage f, because the power function is returning a float, and we're going to then send the base as a parameter and the power as a parameter, and then we display the actual answer. Okay, and that's it. We will do the power function in a moment, but let's first do our basic main function structure here. Okay, next up will be circle circumference. Now, how do we do the circle circumference? Okay, if we quickly zoom out here. Okay, so the circle circumference is with the following formula: pi times 2 times radius. Okay, and that's actually very, very easy. What we will do is we will first ask the user to enter the radius. Then we need to use a scanf statement. Okay, and let's quickly just check the circle circumference is int radius, so the user will only be able to input a int. So we're going to have a radius variable there at the top, and we're going to say ask the user to give that input, then percentage, then radius. Then what we will do is we will go and call the circle circumference function, and then we're going to printf the answer again. I'm going to say the answer is equal to percentage f, and it's returning a float. We're going to call the function, and the radius will be sent as a parameter. And that's it for the circle circumference. Triangle surface. For the triangle surface, we need to go and get input from the user, the base and the height. Okay, so we can copy and paste this. I'm just going to change the variables and the names. So first of all, we need to ask for a base. That's fine. and then we need to ask for a height. Okay, a height variable, so I'm going to create that height variable there. Height. Okay, there's the height variable, base and height. Then we're going to do a printf statement again, and we're going to say the answer is equal to percentage, and the triangle surface is a floating return again, so we will go and call triangle surface, and we will send the base as a parameter and the height as a parameter. Okay, so triangle surface, just need to check base and height, perfect. Then next up we need to go and do the factorial, so we're going to do a printf, and what we're going to do is we're going to ask the user to input n. So input n, we're going to have a scanf statement, we're going to ask percentage d ampersand, and I'm going to call it small n. Small n, and then we will call the printf statement again and say the answer is percentage d, because it's returning an integer as a answer, and we're going to call that factorial function, and we're going to send small n as a parameter. And there we have it. That's our basic layout. Okay, let's quickly go through it. So first of all, I call the display function. Then I ask for the input. I do the switch. Then the switch will check between 1, 2, 3, and 4. And then default. Okay, the default will be invalid input. So the last selection that the user will be able to make is 5 for exit. So what we will do is we will say repeat this until choice is unequal to 5. Okay, so that's how we will stop this while loop. Great. And then for 5 we need to make a case, otherwise it will be under default, and we're just going to say printf, let's say by, and then break. Okay, so that's our case of 5, and then that's it for our main function. Now what we can do is we're going to copy our function prototypes, go down after everything. Okay, I'm going to paste my functions there, and I'm going to create brackets for each function. Okay, so the best way is to copy and paste the function prototypes so that you don't make spelling mistakes in between the function prototypes and the actual implementation. Okay, but just be wary, you need to take out the semicolons and put in brackets. So first of all, we're going to do the display function and test the display function. So what we will do is we will go and do the display for welcome to advanced calculator. So printf statements we will use quite a bit now, and new lines for each. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 4, 5, 6, 7. So first of all, we're going to say welcome to advanced calculator. Next up, we will say power function. 2 is circle circumference. 3 is going to be triangle surface. 4 is going to be factorial function. Then 5 will be for exit, and then we're going to ask the user for a choice, and we're not going to add a new line there. Okay, so that's our display function to display the menu to the user. So there's no return type, so we don't have to return anything after we've done with our last line. Next up, let's quickly go and just do return 0.0 there. This is just so that the function works, but it's not going to do anything now. I just want to quickly first test the display function here. So now we've got our functions that don't do anything, and we're going to run our program. Hopefully there's no errors, so there's no compile error, so let's wait for it to compile. Okay, and here we have our function. So first of all, we can say power function 1, 1. It's not going to do anything. Welcome to advanced calculator. So you can see there's a little bit of a problem there. So it doesn't go to the next line. Nice, but all the inputs are there. Okay, so what we can do is we can add a new line there if we want to, so that it goes to the next line very nicely. Okay, what we can now do is our power function. So how will we do the power function? And the power function is going to be a little bit more difficult compared to the other functions. So let's skip quickly the power function, and we'll get to it last. The circle circumference is actually very easy. All that we need to return is radius, okay, times 2, okay, for the circle circumference, times 3.14. Okay, that's the value of pi, and we can return that value. So circle circumference is easy. Triangle surface is also going to be very easy. We just need to say, oh sorry, wrong button. We need to say base times the height, okay, and then divided by 2.0. So we're forcing it to a floating value. Okay, and then factorial. Factorial is a little bit more difficult, but actually not too difficult. We need to use a counter-controlled for loop as specified here in the question, and as well as a clue. Counter-controlled for loop structures must be used to solve selection 1 and 4. Okay, so we need to have a counter-controlled for loop, and what we will do is I will create a variable called answer, and I will set answer to be equal to 1. So 1 factorial will be 1. 2 factorial will be 2 times 1. So we will always times with 1. Okay, for factorial we will always times with 1. So what we will do is we will say for I is equal to 1, and then I will say I is smaller than big N, then increment I. So what I will do now is I will count through this for loop, count through each, not each element, I don't have to do brackets there. I will count from 1 to N, okay? And the reason why I'm doing this, I need to count from 1 to N, so it needs to count to N, so it's smaller than and equal to N, is then each time what I'm going to do is I'm going to say answer is equal to I times answer, and then I will actually go and do the factorial then. And then I can just go and return answer. Okay, and that's the factorial in a nutshell. Very easy, in fact. Okay, so we have done our circle circumference, triangle surface, and factorials function. Let's build and run first and check. If we have errors, then we need a semicolon. We build and run, and as you can see, here's our program. So what we will quickly do is we will do the circle circumference. Okay, and circle circumference is radius times 2 times 3.1. So let's make the radius 1. Oh, sorry, circle circumference first, and then we make the radius 1. So 1 times 2 will be 2. 2 times 3.1 will give us 6.28, if I'm not mistaken, 6.28. So we know that the circle circumference is working. Let's do the triangle surface. So we select 3 triangle surface. Let's make the base 2 and the height 1. So 1 times 2 will be 2. 2 divided by 2 will give us 1. Yes. So we know that that works. Factorial. We have an example here. 4 factorial. 4 times 3 gives us 12. Times 2 gives us 24. Times 1 still 24. So 4 factorial will be 24. Yes. And then we can exit. So now let's go and do our power function. Okay, and I set the power functions a little bit more difficult, but let's see how we will solve the power function. So first of all, for the power function, I will go and create a counter variable and also an answer variable and initialize it to 1. Then what I will do is, firstly, I will check if the power parameter is equal to 0. If it's equal to 0, I'm going to simply return 1, because anything to the power of 0 is 1. But I'm just going to return 1.0. Then next up, I'm going to check else if the power parameter is smaller than 0. And then if it's smaller than 0, I'm going to do something else, and then else if the power parameter is bigger than 0, I'm going to do something. Okay, so I'm going to check for the power variable smaller than 0 and bigger than 0. Okay, so what I'm going to do inside this is I'm going to say for I is equal to 0, and then I must be bigger than power plus 1. So now I'm counting the other way. So I minus minus. So I'm counting in the other way compared to normal counter-controlled functions. So just go and check this and make sure that you understand that. And then I'm going to say answer. Answer is equal to answer times the base, and that's how I will solve the first part for the negative power, and then I will return the answer divided by the answer, yeah, but we've forgotten one extra base, so I just need to times with base again. Semicolon. Then next up, for our positive power, what we will do is in this we will count in the positive direction, so this will be a normal counter-controlled for loop, and we're going to count in the positive direction, and then what I'm going to say is answer is equal to answer times the base, and then what we will do is we will return, and there's again a missing base, so I'll just say answer times base here, so that it's the same as that one there. And that is our power function. How our power function works. Let's quickly run it, check that there's no mistakes. Okay, so we've got a mistake here. There needs to be a 0. Okay, I like to put in some spaces there. Let's quickly save this again. Now our power function is also done. So we're going to have a, let's say, a base of 1 and a power of 0, and the answer will be 1. Anything to the power of 0 is 1. Okay, so let's do a power function again. Let's do 1 to the power of 5, and the answer will still be 1, because 1 times 1 times 1, 5 times is still 1. Then let's do 2 to the power of 3 will give us 8. Yes, and that's it. That is our program. So we can do one extra thing. We don't have to have that return there. We can also use a functionality called system CLS. So what we can do is we can go and clean the screen. So what we can do is we can say system CLS, okay, CLS, system CLS inside in double inverted commas, and that will make the program a little bit nice and neat. So if we run it, okay, there's going to be one extra thing that we need to add, but if you say 1, 2, and then 2, it will display the answer very quickly and go back here. So what we can do is we can add a printf here in our while loop before we end, and we can say press any key to continue ... and we can just say get. That will be our get char, and then after everything, let's quickly check 1, press any key to continue. Okay, so what we're going to do is I'm just going to add a new line, 2 new lines there, and now our program is nice and neat. So now if you will see, let's do the power function 1, there's the answer, press any key to continue, and it disappears. Circle circumference, there's our circle circumference, press any key to continue. And then 5 to exit, bye bye, press any key to continue, and done. And that's it, ladies and gents. That is our advanced calculator example with the solution for each of the selections: the power function, circle circumference, triangle surface, and factorial function. And that's all from me. Thank you for watching, and I hope to see you soon.